Okay, welcome to the end of course chemistry examination study materials for reporting category number 1. This is matter and the periodic table. Let's get started. So we'll begin with the question, what are physical properties? Well, a physical property is any measurable property which describes the physical state of matter, the physical state of matter. So physical properties might include such things as color, density, temperature, or volume. If I know any of these, then I know something about the physical nature of the matter that is surrounding me. So these are physical properties of matter. The volume of this liquid is 6.3 milliliters. That's a physical property of this liquid. The luster of these metal spheres is an example of a physical property of this metal. It has nothing to do with the chemical nature of the metal. It has only to do with the physical nature of the metal that is making up these metal spheres. The unique densities of these liquids are physical properties. The orange liquid or yellow-orange liquid on the bottom is the most dense. So we always go from most dense on the bottom to least dense on the top. The green liquid on the top is the least dense. So density is an example of a physical property. Density is an example of a physical property of matter. So what then are chemical properties? A chemical property is any of a material's properties that become evident during a chemical reaction. So for example, they may include the reactivity of a substance in water, flammability, chemical stability, or preferred types of chemical bonds to form such as ionic, covalent, or metallic. In other words, anything having to do with the chemical reactivity of a substance is a chemical property. Anything having to do with the chemical reactivity of a substance, not the physical, but the chemical reactivity of a substance, is a chemical property. So, for example, if I drop a couple of Alka-Seltzers or antacid tablets into some water, I see gas bubbles forming. Those gas bubbles indicate that a chemical reaction occurs. So that's a chemical property of this substance. If I take two liquids and I mix them together, to form a precipitate, that's a chemical property. And if I see large amounts of heat being generated, so for example during the burning of methane, that's a chemical property of methane. It's a combustion. It's a burning of the methane. That's a chemical property of the methane as opposed to a physical property of methane. When sodium is placed into water, a highly exothermic or heat-releasing reaction occurs. This is an example of a chemical property of this metal. So for example, if I were to say that sodium has a metallic character, or if I were to say that sodium has a high density, those are physical properties of that metal. But if I say that sodium reacts violently with water, that's going to be a chemical property of that metal. Let's contrast physical and chemical properties with physical and chemical changes now. Changes to matter which do not change the identity of the substance are known as physical changes. So tearing a piece of paper, for example, is an example of a physical change. The torn paper is still paper. So that's a physical change. Melting, condensation, and sublimation are all examples of physical changes since the identity of the substance remains the same. If water or ice, for example, melts, it's still water. If water condenses, it's still water. This is the process known as sublimation. It's what happens when solids turn directly into gases. So carbon monoxide, for example, or carbon dioxide, would turn directly from a solid into a gas. That's a physical change since it's still carbon dioxide. Chemical changes which result in new substances being formed. Cooking an egg involves a chemical change since chemical changes result in new substances being formed. Chemical changes cannot be easily reversed. You can't, for example, uncook an egg. So cooking an egg is an example of a chemical change. Burning a piece of paper is an example of a chemical change. The soot formed is no longer paper and can't be turned into paper. Now let's review the terms intensive and extensive properties. Intensive properties are properties which are not dependent on the amount of substance present. For example, density. It doesn't matter how much material I have, the density of that material remains the same. The boiling point of water is 100 degrees Celsius. It doesn't matter if I have a little or a lot of water. the boiling point remains the same, and the same is true of specific heat. All these are intensive properties because they don't depend on the amount of substance that I've got. Extensive properties, on the other hand, do depend on the amount of substance present. If I have a large amount of matter, then it may be massive, and it may have a high heat content, and may be have a lot of volume. So mass, heat content, and volume are all examples of extensive properties. Extensive properties. Let's distinguish solids, liquids, and gases. The particles of solids are tightly packed together. They have very little kinetic energy. They don't move around very much. Those of gases are relatively far apart and have a high kinetic energy. They move around a lot. But those of liquids are somewhere intermediate between solids, liquids, and gases, somewhere in between. So what's matter? Well, it's everything around us that we see and everything that we don't see. The air, for example, that we don't see is still matter. It has mass and it takes up space. The properties of solids are that they hold their shape. If I have a rock, for example, on a desk, it's going to hold its shape. It's not going to change shape over time. It has a fixed volume, right? So solids they hold their shape and they have a fixed volume. Liquids, we know, they do not hold their shape. They take the shape of the container that they're in. So they have the shape of the container that they're in, and they have a free surface. They have a fixed volume, however. The volume of the liquid is fixed. Gases, remember, the particles of gases are far apart and moving very quickly past one another. In other words, they have a high kinetic energy. They take the shape of their container and the volume of their container. So the bigger the container, the larger the volume. Let's distinguish between pure substances and mixtures. What's matter? Well, it's everything around us. And everything around us can be distinguished or separated into pure substances and mixtures. Let's talk about pure substances. Pure substances include the elements. Those are all of the elements of the periodic table, and the compounds. In other words, the combinations of elements. So elements might include such things as sodium, potassium, rubidium, carbon, nitrogen, oxygen. All of those are elements, and there are many more. Compounds are combinations of elements, things like water, H2O, CO2, carbon monoxide. All of those are compounds. So both elements and compounds are pure substances. Mixtures, on the other hand, are mixtures of substances, mixtures of pure substances. If I take sugar and I place it in the water and stir it, that's a homogeneous mixture. It's the same throughout. That's what we mean by a homogeneous mixture. It's also sometimes known as a solution. Heterogeneous mixtures, on the other hand, are not homogeneous throughout. If, for example, if I were to get a bucket full of river water, in that water might be water, of course, but there would also be sticks and bugs and leaves and all kinds of things. And they would not be homogeneous throughout. We would call that heterogeneous, or a heterogeneous mixture. So pure substances include elements and compounds. Oxygen and sulfur are both elements. The oxygen in this tank of gas, of oxygen gas, is an element. It's a pure substance. But so is this sulfur. Sulfur is also, it's an element, it's a pure substance. But water, a compound, is also a pure substance. It's a compound, and so is carbon monoxide, the gas that comes out of the exhaust systems of our cars. Those are both pure substances. The container on the right contains pure water, and the one on the left has dirt and other contaminants in it. It's not a pure substance, it's a mixture. It's a mixture. The gold and silver bars on the left are pure substances, and the metals on the right are not. They are mixtures of different metals. Those on the right are known as alloys. So these are pure substances. Gold and silver can both be found on the periodic table, but this is an alloy. This is a mixture of metals, a mixture of